Hello and welcome back to Compiler Programming. In the last video, we made quite a big progress towards removing all the hard-coded stuff from the PE32 executable encoding code that we have. And today I'm going to continue working on that. In particular, the next thing that we need to do if we want to stop having these hard-coded sizes here is to try to encode the sections ahead of time. And in particular, we can start with the rdata section and try to figure out how would we do that. First thing is we should try to estimate how much size we actually need. So let's try to have another function that would do that for us. So we say void estimate max data section size, and we pass in the program. Okay, what will that do? Well, that thing needs to know some numbers. It definitely will go through all of the import directories, so we can take the code from here. I guess let's just copy all of the stuff from these things and try to clean it up and keep only the things that we need to understand the size. So it won't be actually void, it will be 64, and we're gonna put everything here. Okay, so we definitely going through all of the import libraries. We get library, we get through all of the symbols, we get this symbol, and now we need to figure out what is the size that we are gonna need to encode it. In general, we can also try to just encode it right away. Let me think if we will need to know something about that. So we definitely need to know the relative virtual address of this, but now that I'm thinking about it, we should be able to get it, because the size of the headers is almost always going to be below the 1000. So the virtual address here is, or the size of headers is 1000, and virtual size of image, virtual section, yeah. So basically we can just add an assertion here that says something like, okay, how do you do this? Well, I guess we say define PE32 expected virtual size of headers, and or even better, what we can do is, after we do this stuff, we know the size, or we know the virtual address of the section, so we can just pass that to a function that would generate the imports. And that sounds good. Okay, so well, let's say it will return us a buffer, and buffer is our data section buffer is encode our data section, and we pass in the program, and we pass in our data section header. Yeah, that actually sounds good to me. So we take this header, we say that it's going to be one of the arguments. And since we have the header, we can convert this to relative virtual address. So the way this is gonna work is we need to change this macro or place it with something else. We don't need the section header parameter anymore because we have the header here. So in general, we just need to figure out what is the buffer plus buffer occupied plus the offset in that section. Okay. I guess the first thing is we do need to have a buffer, and in here it's probably okay if we will eventually dynamically size it. For now, I will just keep it as is. Add fix me, dynamically resize the buffer. Okay. Or we can use a bucket buffer or something like this. It's fine. And if we try to call this now, what did I call this? Encode our data section. That's fine. And I can return buffer. We can replace exe buffer with our buffer everywhere. And that's gonna be fine. Let's try to build this. It will definitely miss some stuff. Okay, so that's this makes sense because this was a macro that is not defined anymore. Let's figure out what we need to put here. As I said, it's going to be buffer occupied plus header virtual address. Or I'm going to change around the order of these because it makes it more obvious what we are doing. So that's fine, but it is still unhappy because we don't have function anymore. It's called symbol now. Okay. Still not great because it is actually U32, I guess, or S32. Let's cast this. Yep, that's good. This puts the information about the import directory into the optional header. We have a couple of options. We can pass in optional header, or we can somehow return this. I think for now I'll just pass in the header so it is easier to deal with this stuff, but later on we might want to fix it. And optional header, what is the type of that thing? The type is image optional header 64. So that's what we can pass into here. And we don't know what IIT directory index is. That's fine because this enum is defined here, but we can just bring it up a notch. Okay, making progress. This file set to RVA can be replaced with this stuff. So that's fine. Maybe I should turn it into a macro though. let's do it. Define get REA. And we can make it a function like macro that just does this stuff. And now we can use it everywhere. And let's right away add an undefined. Get REA. Good. That's nice. We can put it here. We can put it over here. Let's make this window slightly bigger. That's the same, the same. Okay. Here we can just say header. Because at this point we already do know at what location we're gonna have the raw data, again because we already calculated where the headers end, so we do know where this first section is gonna start, so this should still be pretty safe to do, except that the size is not gonna be that. The size is going to be just buffer occupied, I guess. Yeah. Because this is the start of the section, but because we now have a separate buffer for this, we can just do this, which is nicer as well. So this is REA. This is also REA. And this is REA. And now we have REA minus import directory REA. That's okay. And we are returning buffer. Yeah, that should return buffer, because previously I thought it would return us an address, but that's not what it returns, so we can have to change. Here is gonna be optional header. Optional header what? At this point we don't have an optional header, so let's guess like this. Needs to be over here. Her data section buffer. Okay, so we have it, but we don't yet do anything with it. Well, let's try to do something with it. We have this stuff over here where we calculate this stuff. And let's remove all of this code and try to write it out differently. So we have our data section buffer, and we need to write it to this exe buffer. Well, the way we do this is we say s8 star our data memory is gonna be exe or buffer allocate size exe buffer, and then our data section buffer occupied. And then we just need to copy. So map copy our data memory, and then we have this our data section buffer I forgot what is the name of that. It's also called memory, so that's good. Data memory, and the size is our data section buffer occupied. So we're just like straight up copying memory. At this point, we could even be probably writing directly to the file, but I will need to let's check how to do it correctly with Windows APIs. Okay, let's see if I have messed it up or not. We can just run the tests and see what's going on. Great, so it looks like it is still working, even though now we are doing the encoding of the this section ahead of where we were doing it before. And the reason it's important is because we are writing out the section headers after we are doing this. That means that whatever we are putting here should actually now be correct, and we could be calculating that from the size. So let's get rid of this stuff, and we can say instead of IAT, just say our data segment. We still have our assert. Let's verify that it would fire, that we are still doing the right thing. Yeah, so that's fine. And now we can actually update this size to be correct. So this virtual size and size of raw data. Just making sure that we are not actually using size of raw data anywhere in here. Yeah, we are not. So that's very, very nice. Okay. That means that what we can do is update it. I'm not sure if we should do it in that function or somewhere here. Let's do it in that function, I guess, since we are passing the header there anyway. So let's do it. Data section header. Ta-da-da. Okay. Size of raw data and virtual size. Okay, we are done over here. And I'm just gonna say that header misc virtual size is gonna be buffer occupied. So this is pretty simple. And the size of raw data is gonna be a line, or S32, a line of buffer occupied. So we need to cast these two. And we need to align it to PE32 file alignment. That seems correct. And yeah, I can add the assertion for now that this is indeed the case, that we calculated the right things. And then I will remove that assertion, because once we start actually putting more stuff in there, it will be different. So this is not misc, this is just size of our data. Okay. Let's see. Did I call it something else? Well, I guess it's align U64 I can use. Align U64, and then I'll test it. Okay. Looks good. So we are doing correct calculations. That means that now we can remove this stuff, and we can remove this stuff. So let's do it like this, and let's do it like this. That's very, very nice. So one less stuff to worry about, as Forrest Gump used to say. Okay, apparently not. So what did I mess up? Okay, that's fine. Are we not writing to the right thing? So we are writing out sections header here, so at this point they should actually be correct. This is interesting. I guess the issue is that we yeah, we are using probably here. Yeah, we're using size of raw data as size of initialized data. So this is something that we will need to change as well in here. Oh, optional header size of initialized data is this stuff. Size of raw data, this is just header. Whoop, that was a lot of copy paste. Cool. Let's check again. Great, we are still working. So let's remove virtual size. Still working. So we can remove this stuff, and we can say that this is basically, just say 0. And finally, size of raw data. Okay, so size of raw data is used somewhere. Where are you used? Okay, not here. It is used over here. So now I have a bit of an issue. I don't have so this virtual size of image, it is necessary for this thing. At the same time, we will need to know some information to make that happen. Okay, so it's time to do it slightly better. What we can do is we can take this stuff and bring it up, because we do know what is the virtual size of headers. So let's grab this and say S32 virtual size of headers is this thing. So we start like this, which makes a lot of sense. And once we know the virtual size of headers, we can actually do what we want. In particular, we will just say our data section header virtual address is virtual size of header. So our data section is the first one. We can even move all of this stuff up a bit more to before we create the sections, and that would mean that we don't need to patch it here. Instead, we can just say that, okay, you started this address. This is very well known. Okay, and then we can put you over here. Obviously now it will complain that, oh, I don't know what is... Okay, yeah, we do have to have it below, so that's fine. We can keep it like this, that's okay. But we obviously don't know what the optional header is. And what we're gonna do with this is we're gonna change what the encode our data actually returns to us. And what it will return to us is a custom object that will say encoded our data section. And then we say buffer, data section buffer is going to be just a field of that struct. Section, oops, buffer. Okay, so what are you? Well, we'll just define this new struct here. The struct encoded our data section. It will have a buffer in it, and then it will have the fields that we need from optional header. So we'll just try to build. It will tell us which fields from optional header we are using. So we need to return IAT directory address and a T directory size. So let's do that. Okay, we say IAT virtual, or actually, sorry, S32 IAT virtual address and IAT size. Okay, that's fine. Now we can do encoded our data section result is this. We say buffer is so, and then the rest would be just 0. That's fine. Say buffer star, buffer is ampersand result buffer. Let's move this comment over here and continue our stuff. So get array now needs to be like this, and we can remove ampersand from the buffer. Now, so here we just say result IAT virtual address is get array, and we remove this stuff, or more precisely, I will just aggregate these things and later copy them into the right place, so don't forget something. Okay, result IAT virtual address, result IAT size is S32 buffer occupied. Okay, and what else do we do? We also have address of import directory and the size of import directory. Okay, that's fine. So we have import directory array and import directory size. let's call this for consistency. Okay, making progress slowly but surely. And now we can put it directly into result. So result import directory RVA is RVA. Again, let's continue accumulating what we need to fix in the code later. And the last thing here is result import directory size is this stuff. Okay, that's good. Here we just need to change dots to arrows. And we also need to have this size of initialized data, but this is pretty straightforward because this is just buffer occupied. So we don't even need to put a separate field to this stuff. And return result. Okay, it built, but right now our executable is in very bad shape because we have not dealt with the fields that we extracted. So let's do just that. We need to take these guys and move them over here because that's the place where we actually have the optional headers. So virtual address is gonna be our data or encoded our data section. Is this the right name for it? I guess so. Yeah, it's called our data section. Cool. And we say IT RVA. Let's move it to the new line. Here we say the same thing. We just say IT size. And the same thing here. We just put the right field. Directory size. Okay. And the size of our data here is simply encoded our data section, buffer occupied. Which needs to be truncated as well. Cool. Well, let's see how that works. If this is any better than it was before. Okay, it still works here, but the question is, does it work if I remove this number? Because that's what was giving us trouble before, and it does. Great, good. So I think that would be enough for today. We did a good chunk of work, namely now this encoding is actually more or less independent of anything else that happens inside of here, right? We are just passing a pointer to this section that doesn't really have anything in it, and the rest is calculated from it. There is a bit of work still left to do because we are not having any data there yet, but this I will handle in a separate video. I think we'll have another Hello World-like episode, but now with executable, which will require us to actually put the string somewhere. When we were doing JIT, it was simpler. We just threw it out there and could point to any memory, but here we actually need to do something about it. And the last part of this series is to deal with the code. But now that we have encoded successfully our data section before we encoded the main header, there should be absolutely no issue with us also moving this encoded section, encoding of code somewhere up as well. So this is very, very promising. Okay, one thing I do need to do is I do need to say free buffer our data section buffer, because otherwise we are leaking memory. Let's check that. It still works. Everything's fine. And with that, I thank you very much for watching, and hopefully see you next time when we finish up the encoding of the machine code. For now, goodbye.